So most of you have done the group part of your assignment. Some of you have done your rationale now. Some of you have started processing the data. Remember, I made a video on how to do these. So there's the link to the video. So let's just imagine you've done all of that stuff, right? I'm working through evaluation and conclusion today. You need to justify your conclusions. So for this task, you need to answer the research question. You need to mention the key data found in the experiment to support your conclusion. So let's have a look at this. I'm going to go through an exemplar available online. So in this particular one, they're looking at the relationship of a projectile, so its spherical cross-section and the displacement of this projectile. So you know what projectiles are. They've gone through the rationale, they've done all that stuff, method, etc. So justified conclusion. So they've mentioned data. They've said the cross-section increases from this to this. The horizontal displacement goes from this to this. See that in the green? Mention data. They show how it supports the conclusion. So they're saying graph 2 showed, with the uncertainty of the measurements, a relationship between the two. Answers the research question. Projectile displacement versus cross-section, yeah? Describing the relationship, answering the question, using data. Next bit, justify discussion of the validity of the experimental process. When you're talking about validity, you're talking, was it accurate or inaccurate? To do this, you mention percentage error calculated. So hopefully you remember how to calculate percentage error. So this is a formula, percentage error. I'm not going to go through it. So you can see in this conclusion, mentioning that percentage error. So they also talk about, was it precise? So do you know the difference between precision and accuracy? Have you been taught this? So you hopefully have seen something like this before. So the target idea, if it's all in the middle, what you want, it's high accuracy, high precision. If all of the numbers you got were around the same number, but it's like completely different, so like the gravity constant, if you got all these results, the gravity constant is 11, that means it is precise but not accurate, okay? If you're looking at accuracy, validity, look at percentage error. So a very high percentage error, not so accurate, not so valid. Justify your evaluation of its reliability, so the precision of it. That's when you mention the percentage uncertainty and absolute uncertainty. Very low percentage uncertainty, absolute uncertainty, it's very precise. So you can see that's what they said here. This suggests the precision of each individual measurement was high, but the method itself had significant random errors.
So what's a good rule of thumb? Like, where would you cut it off too much percentage?
More than 10%, it's not very precise. When you're talking about the reliability, you need to talk about the errors that happened. So systematic errors, someone accidentally measured an extra 0.5 meters on the measurement or something. So that's like a systematic error. Random errors, you can't control. So you could easily fix that systematic error because you accidentally added 0.5 to your measurements or whatever it is when you did the experiment. Random, it's a bit harder. So they go through some of their errors in their experiment. So they talk about the wind factor, because it's a projectile, there's wind, potentially affecting the experiment, which is a bit more random. And they talk about the assumptions they made as well. How are these numbers associated with your experiment? So you've got to talk about how they relate back to the experiment. Don't just say, oh yeah, I had a low absolute uncertainty and percentage uncertainty, so it's precise. Okay, last thing before you just get back into it. Suggested improvement extensions, pretty similar to tasks you've already done. Just remember to relate these improvements extensions back to the experiment and how you're going to modify it so you don't get those errors. So you're going to try and reduce the systematic random errors by improving the experiment, extending the experiment.